In this video we're going to look at various types of algebraic fractions, and the first one that we've got here is we're being asked to simplify this particular expression. So in the numerator we have a trinomial which will factorise. I won't explain that clearly now because that was part of the last video. In the denominator we have 3 minus x. It would be really good if that was x minus 3, and in fact there is a relationship there. 3 minus x is equal to minus outside of x take 3. Now we can do that. We can cancel a factor top and bottom, which basically means that we're left with -1 on the bottom. So x plus 2 divided by -1 is the same as negative x plus 2. Okay, the next video we're adding these terms and they're basically fractions, so you need a common denominator. So the common denominator that we'll use here is x plus 5 x take 5, because we know from a difference of squares that x squared take 25 is x plus 5 x take 5. And the 6x already has that denominator, so that's no drama. But the x plus 2 doesn't have that denominator, and in order to get that denominator we'll need to multiply top and bottom by x take 5. So that's over our common denominator. So that's 6x plus. Now, when we expand these two brackets out, we'll get x squared, take away 3x, take away 10. So, after we collect those like terms, this will give us x squared plus 3x take away 10 over our lowest common denominator, and the top line will factorise to x plus 5 x take away 2, which is on x plus 5 x take 5. So we get some cancelling here, and due to space restrictions our answer then is x minus 2 over x minus 5. Okay, so this one is different because we've now gone to divide, so we don't need to worry about things like common denominators, but we've got lots of trinomials and things that factorise here, so I'd suggest that that's where we start. So x squared minus 9 is the difference of squares, so that's x minus 3 x plus 3 over. We have a trinomial on the bottom, which will be x 3 and 4 add to 7 multiply to 12, so 3 and 4, and they're both going to be add. So straight away that helps us. Dividing by, we have a common factor of x outside of x take 3 over 4 outside of x plus 4. There's nothing there that will cancel yet. Now what we need to do is turn the divide into a multiply like you do with numbers. You need to multiply by the reciprocal. So that's going to be x outside of, let me start that again, that is 4 outside of x plus 4 over x outside of x minus 3. So you can see there's going to be some more factors will cancel, basically we're left with 4 over x. This one's a more complex one, and what I'd suggest that you do here is this is written as a fraction within a fraction. It's quite difficult to deal with. I'm going to suggest that we write that as 4 plus 2 over x divided by, so instead of using fraction form, we use the divide sign form, 3 over x plus 2. Now, we can't turn that divide into a times yet because we don't have a single fraction that we can take the reciprocal of. So what we've got to do is go for common denominators so that we end up with a simple fraction with a single numerator and denominator. So this first lot, common denominator of x, will give us 4x plus 2 in the numerator. Divide by common denominator of x plus 2 will give us 2 lots of x plus 2, take away 3 in the numerator. Okay, so that will give us 4x plus 2 over x, divide by something over x plus 2. So it will be 2x plus 4. So the 2x bit is important. 2x plus 4, take away 3 is 2x plus 1. So continuing that up here, now that we have a single fraction, we can go with multiply by the reciprocal. Now, what I should have done, which I will do now, is 4x plus 2 I'll write as 2 outside of 2x plus 1, so that we can cancel those two factors out, and we basically get 2 lots of x plus 2 all over x.